Good afternoon, everyone. My name is Ben Malec. I work for Paylocity. We are an online provider of payroll and human capital management resources. And we've been using Redis for about 3 years now. We started originally just using it as a session state store. I got tasked with finding something we could use for session state that had high availability and we could scale. And pretty quickly found Redis, and kind of like Salvatore was talking originally in the keynote, it's just an instant-on thing. It was like, get things set up and going. It's like, wow, this thing's really great. So we started going into caching after that. And over the past couple years, we've expanded our caching solution to incorporate both InProcess and Redis as part of the whole cache. And I want to kind of go over what we've come up with, see if it's something that could be useful for you. So I'd like to kind of step back a little bit to give you some ideas of the issues we're trying to solve, the challenges we were running into. So this is, everyone remembers this, well, maybe not everyone remembers this from, 18, 20 years ago when we first started writing web apps. So it's like have a bunch of web servers. Oh, wow, we got a web farm. And I'll be talking to SQL Server, and it's easy model to program against. Works really good until one day you're like, let's try to log 50 users on at the same time and see what happens. And all of a sudden, SQL Server falls over dead, and you say, oh, we've got to do something. What are we going to do? Pretty quickly, you start realizing that a lot of the data you keep querying for, it's the same values over and over again. I always like call them cacheability quadrants. So there's certain data that's really good to cache, stuff that doesn't change a lot, but is accessed all the time. Opposite side, you don't want to be trying to cache something that really is never used and is changing all the time. So you kind of find these little things that are like, okay, these are good things to cache. Names, phone numbers, things that don't change a lot. And you say, oh, I know what we're going to do. We'll just toss a little in-process cache on all our web servers. And our pattern here is whenever we need data, we'll look at the in-process cache. We'll say, if it's in there, great, just run with that. If we don't see that, we'll say, okay, we'll run out SQL Server, grab the data, place it in the cache for the next access, and go. And this works pretty good, but it brings along some baggage. So one of the things you're having is you're probably going to stick a value in the cache, and you're probably going to give it a time to live of 2 minutes, 5 minutes, whatever. Well, now you've got a lag issue. So because you're always checking the cache first. So if there's some background process or something that updates your data in the SQL backend, the users don't actually see it for a while. So it's kind of it's a bad user experience because they're just like, well, wait, someone told me they updated my phone number, but I'm not seeing it. And the usual solution to it is like, okay, we'll just keep creeping down our time to live times. But that's not a really good solution. It's a little better for the user, but they still see some laggy data, and we're hitting the SQL backend more often. What'd be great is if we had some type of way to push that from your SQL backend to say, hey, you know what, these values changed. Let's refresh these caches. But it's not really always straightforward to implement. I remember one time, let's see, tell me if this will scale or not. Someone was doing a SQL trigger that actually updated a file on the file system, and then all the web servers were using file system watchers across the net. That did not scale. Did not scale. Another problem you run into when you have multiple in-process caches or in-process cache per each web server, so they're all independent. So over time, you start getting the cache expiration times fall out of sync. So you'll have one cache or server one, you'll have maybe the value will expire in a minute. Cache 2 or server 2 is 5 minutes. So now you've actually got a worse user experience because the data's changed in the underlying store. But depending on which web server processes the request, you may see old values, you may see new values. So at first you're like, oh, I'm not seeing a bad value. Wait, now I'm seeing a good value. Now it's bad. It's really a horrible user experience. It's another tricky one to solve too, because now I'm going to have some way to communicate between all the nodes and basically inform them of updates. And a lot of this stuff was challenges we were running into like 10, 15 years ago. It's a little easier now. You've got things like gossip protocols, things like that. But really, those still are not trivial to implement. Another real big issue you run into is, say, servers 1 and 2 both update the same key at about the same time, and now they send a message to server 3. Due to network latency, you really don't know who was the actual winner, who wrote last, because the first message may have been delayed by, got caught in a router or something where we had to drop a packet or something. So it gets really tricky to try to figure out actually which data is correct, which is the newest data. Real easy to flood, actually all these cases, real easy to flood the network with sync messages too. I could spend the rest of the session just talking about horror stories. Cache stampede, another one. This one always surprised me a little bit. I never really thought it'd be as big an issue as it does or tends to be. So we have all these in-process caches, and they all need to refresh their data from the SQL backend. So when we start doing things like a pool deploy, where we take out half the web servers, and then we update software on them, we bring them up, we drop the other half out of the load balancer. Well, now all of a sudden, you've got, say, 10 servers coming online, all with empty caches. And as time goes on, people put more and more stuff in the caches, and they start saying, oh, wouldn't it be nice if I really preloaded all this data? So now you have just these horrible SQL hits coming saying, I need to grab, 1,500 rows, 2,000, 5,000 rows to shove in my cache. And we're doing this, all the servers are doing this at the same time. So I had a story I remember well where we were having exactly this. We did a pool deploy, and the DBA comes up to me. And he's like, what are you doing, Ben? We just keep seeing these same requests for the same data over and over and over again. You're killing me. And I had to explain to him, I'm like, no, this is actually the software that's supposed to reduce the database hits. So it really is, yeah, it was ironic. It's ironic, but it's a reality that I'm assuming a lot of you have run into. So it's an easy solution to a lot of these problems. We can just toss the in-process caches out, and we can just replace them with Redis. And this is a real classic Redis use case, mainly because it works so well. We've solved the consistency problem across the servers because there's just one source of truth. So every time web server needs to get data or a cache value, they'll just go to Redis. Everyone's looking at the same values. Can help a lot with the data lag. So, if we're clever, we'll always do write through things. So whenever we write to the database, we'll also write to the Redis layer so everyone will see things, all the current data. Cache stampede. So now you just need one hit to the SQL backend to pull data into Redis. I mean, I guess you could have a cache stampede at the Redis layer, but you'd have to work really hard to get enough throughput to actually get Redis to sweat. The downside with this, though, is that every time we do a Redis, every time we hit Redis, we've got a TCP round trip. So Redis is incredibly fast, but you still have a few milliseconds here that add up over time. And so we were using this at Paylocity, where we basically had a single Redis caching layer, and for almost all the teams, worked really, really well. Everyone was happy. More people were coming on board, all as well. We had one team, though, that they really pounded the cache values. I can't remember if it was a MVC filter or something that, every page request, they had to grab a bunch of values. And Kevin, one of the devs on that team, he comes to me, he said, Ben, wouldn't it be great if we kept Redis, but we stuck an in-process cache, too, so it'd be a little bit faster. And so the good thing, Kevin's a remote employee. So the wonderful thing with remote employees, so I'm like talking to him, and I'm just like, oh God, not this again. Okay, Kevin, tell me more. So he says, yeah, you know what? This data is really important. We can't have any inconsistent data across the servers. We don't want any lag. We need fresh values. Obviously can't blow up the network. So at this point, I'm kind of like, okay, Kevin, I'll get right on it. And I didn't really get it right on it, but I did throw it on the back, kind of on the back burner, and just kept thinking about it. Because the one thing that changed here is that, so I've seen lots and lots of attempts to solve these problems in the past that, I mean, at best it was a mediocre solution. At worst, it did blow up the network. But the new thing we had here is we had Redis. And it's something that, at the time we hadn't used that much. So it's like, okay, how can we use this and leverage that and kind of hit the goals that we're trying to do? And so, again, this guy's kind of moved forward with this in the back of my mind. And one of our other teams then was using SignalR. and they were using a SQL backplane and not having good performance with it. And they found out, they're like, oh, I can use Redis as a SignalR backplane. So they came over to me and they're like, hey, do we have enough bandwidth in our Redis infrastructure and stuff to do this? And we do the calcs and we look and everything's looking real good. And so they switched over to the Redis backplane, and it was working. I'm sorry, I forgot to go there. This is what I'm talking about. They got it working with the Redis backend, and it worked really well. And I was kind of looking at it, and I'm like, oh, they were using PubSub basically to implement the SQLR backplane. And before that, I always found PubSub really kind of interesting. I was like, okay, I've got this really fast key value store, and it has PubSub thrown in. Okay. But the thing is that for what the things we needed to solve with this cache solution is that actually it was a perfect fit for it, because now all of a sudden we have an easy communication easy communication implementation to talk between all the nodes. It's something that we could use so if there's ever a change in Redis, we could push that up to all the clients. We can sync everything across. So we've got the communication part, but now it's like, okay, well, what are we going to send? And one thing we could do is we could just, whenever there's a data change, just broadcast all the data to all the nodes. Unless you're very sure that your keys and values are very small, you will saturate the network quickly, especially if you're going across 50, 100 servers and every single data chain has to be broadcast to everything. It's a low efficiency solution, so we're going to broadcast these data changes. There's a lot, in our case, the cache is shared across web servers, application servers, other things, a lot of different applications, a lot of uses. So what a web server may be very interested in may have no relevance to, say, one of our batch servers. Again, due to network latency, we keep having this recurrent theme, trying to figure out who's actually won. Because the last thing what we don't want to do is we don't want to have some servers thinking that this is the correct value and other servers thinking this other value is correct. Not a good thing. Another approach we could do, instead of sending the data, we could just send the keys. And that actually helps a lot. That helps, it's obviously less network traffic. It solves the consistency issue now, because now we're just telling the nodes, hey, you know what? You need to go check your data, or you need to refresh your data because this data point's invalid. And we'll just go to Redis. Redis is always for this cache at least, it's always the source of truth. If we ever have a question, what's the correct data, Redis always has it. But Redis supports really large keys. So does anyone use it supports half gigabyte keys. Does anyone use a half gigabyte key? No, good, thank you. Because I'd be very nervous about if someone actually did that. And I can't quite come up with a model where someone would. But you know what we do see is we do see keys in the hundreds of bytes and probably go up to the thousands. Because as time goes on, we find a lot of teams, one, we don't want to get cache collisions. We're actually sharing our cache infrastructure over a lot of different products. So we don't want keys to collide. So they'll tend to run longer keys. They'll use their app code and a bunch of other things. And it's just easier to read these things too. If you're trying to debug or pull up a key, it's like, oh, like employee and the employee ID, the company ID, things like that. It's very, very, very developer friendly. So we could do the keys, but there's still that risk that we could blow up the network because there could be a lot of long keys going around. So again, kind of backburnered this thing. And around that time, we started working with Redis cluster. I don't know how many folks are familiar with how the cluster is actually implemented, but they basically, you have several Redis nodes. Each one's responsible for a subset of the data. And the way they figure out which keys map to which nodes, they use what they call HashSlot. So they take this 16-bit CRC, and they mod it by 16K. And now for every key you have, you get a bucket that goes into. And a client will know, it can calculate this HashSlot for the key. And it also knows it can query the nodes and say, what's your mapping? Which nodes are responsible for which HashSlots? And we can just push the data out. And we use clusters, works great. But in this case, where we're trying to look at synchronizing the caches, it was kind of a little bit of a breakthrough moment where it's like, well, you know what? If instead of me sending keys, what if what if we actually just broadcast this hash slot? So now, regardless of key size, we're broadcasting a 16-bit value that identifies a group of keys. And so now, even if you have that hypothetical half gigabyte key, all you need to send is 2 bytes to identify the hash slot. Again, we're not sending values. We're just saying, hey, you need to invalidate your data. Look at Redis. Redis, again, always the gold standard for the data in this cache. But now we've got a new challenge. And the challenge is that when we invalidate a key, we're going to invalidate the hash slot. All the keys with this hash slot are now invalid too. So we have less information. And that really turned into the implementation challenges. Okay, so now we're invalidating groups of keys at a time. How are we going to do it? Obvious solution, we'll get a message saying this key slot's invalid. What, deal with it. And the client could run through their entire cache and basically calculate this hash slot for each key. And anything that matches they could evict. But you really don't want to do that, especially caches tend to grow as people get used. They're like, hey, this is great. I'm going to cache this and that and more data. And all of a sudden, the next thing you know, you have 1 million keys. It's pretty easy to get that many keys in a cache. So what we thought we would do instead is what if, instead of trying to do that, we'll just have an array that we basically keep track of the last time this hash slot was updated. The other part to this is that when we write entries into the cache, we'll write the time that they're also put in the cache. So now we have a little thing where we can do we can basically check when were you placed into the cache, when was this data last updated by someone else. So it looks kind of like this, whether we've got, again, a simple array of unsigned shorts, 16-bit integers. The index in each array is the hash slot. So if I calculate hash slot 100 for this key, I can look in the last updated, the 100th entry in there, and it'll have the timestamp that was last updated. The other thing is now when we put things in the cache, so we've got our keys, which kind of a traditional Redis-looking key. We're also going to add, excuse me, the hash slot, so we don't need to recalculate it again, and we'll also put the timestamp that this entry was put into the cache. So retrieval looks something like this. Basically, whenever we got a request for data, first thing we're going to do is just say, are you in the InProcess cache? If not, obviously we have to hit Redis. If you are in the InProcess cache, read the cache entry, grab the timestamp that you were written to the cache, look up the timestamp in the last updated array, compare the two, and then you can say, am I expired or not? If I'm expired, then we're just going to go through the other route. We're going to read from Redis, we're going to calculate the hash slot, and then we're going to stick the value into our InProcess cache, so the next time around, we don't have to go through all this rigmarole, and we'll return the value to the client. Adding to the cache, similar, it's pretty much what you expect. Try and push some data in, we get the current timestamp, we calculate the hash slot, write to Redis, then write the entry, and then we publish an update message through Redis PubSub. Works really good, but there are a few challenging timing aspects. The biggest issue we have, so the thing we never want to do, we never want to have a client that has old data that it thinks is current. So it'll keep serving up this old data when everyone else is serving up the correct data. And we're updating the last updated array with async message handlers. So this update may happen at any time. So the tricky situation is, say we're going to add a key to the cache and chugging along, we say, okay, we write the value to Redis, and then just after we write to the value to Redis, we get an update message from another node saying, I updated this hash slot. So now, who won? We really don't know because, it take some time to write to Redis and come back? Did we receive this message in the meantime? What's going on here? A couple ways you could kind of solve it with a master clock where all the nodes would sync to some type of clock. So we have this clock that everyone just says, okay, this is the correct time, and we'll just go from there. Could use something like distributed lock. Redis is great for implementing distributed locks. But the problem is I always look at like concurrency and consistency. It's kind of a spectrum. So like locks, distributed locks are great for consistency, but your concurrency drops to nothing because you basically block everyone waiting for this lock to expire. So instead what we did is very, very careful order of operation. So very, very simple concept. In certain situations, it can be tricky to get right, but it's very simple. If you're looking at this and saying, it can't be this simple. Sometimes it can be. So because Redis is the source of truth for our cache, really all we need to know, we don't need exact timing, we just need to know if the possibility that the data in Redis is newer than the data we have in our local process, in our in-process cache. So simple things, like, if we write to Redis first and then send out an update message, regardless of any latency or anything, the client will always get that message after the value's already been put in Redis. So when it goes to Redis, the right value is there. The little trickier situation is when we're writing, and what we always want to do is we always want to grab the timestamp at literally as soon as we go into a function, say, what is the current time? So then as the timestamp moves forward and we're going through this process, doing our process to add the key, whatever we're doing, if we receive an asynchronous message that gets processed to update last updated array, it's going to have a timestamp certainly no earlier than when we started. Crucially, this allows us too that we don't have to sync times across servers. So if we're doing everything based on our local time. So if there's any server time, some skew across the servers, we don't care because we're just dealing in local time. And just kind of a silly little diagram, but just again reinforcing, if we write to Redis first, that's one, and then we send the invalidate key. When this web server 2 looks, it's always going to see the right data. There's one real tricky aspect, or one tricky situation left though, and that is, so we're using a stopwatch. It's got a resolution of 300 nanoseconds or something. But you could feasibly have an operation that all occurs within the same timestamp. So that would get you, okay, we updated value and we received, and we also received an update message, and it happened at the same time. And it's a little bit easier to think, imagine it in terms of minutes. So like, say we're just storing these times to the value of minutes. And, oh, you know what, I wrote my value at noon. And guess what, we got an update message at noon. Well, which one actually happened later? And if it was in Salvatore's stream session yesterday, the way they solve it is I think they're using milliseconds, and then they append like a -1, -2, -3 to get the sequence right. Again, that's going to require some type of lock though, because we're going to have multiple threads looking, and they're going to have to say, wait, we're going to have to lock, get me the next one, because we want to keep those sequences incrementing. And I really didn't want to do that. I'm really trying to push for a real high concurrency setup. And it finally hit me. Because Redis is the source of truth and we're not so concerned about actual timing, when we actually come into these functions, whenever we're writing to our in-process cache, we grab the timestamp, you just decrement it by 1. And what happens is that kind of fakes that it's like, oh, this happened a little bit, our write happened a little in the past. And it lets us then, so if something, we get an update during that proc, we know that we will always have we'll write our timestamp to the local in-process cache with a time fudged a little bit in the back, and what it will cause is the next access will force a read to Redis. A couple things we ran into when we first implemented this. We were really surprised. We were like, this is going to be great. We're going to see like one hit to Redis. It's going to get into the in-process cache, and then it's just going to live in there, and everything's going to be hunky-dory. And we saw right away that it was like we're seeing a lot more traffic to Redis than we were expecting. And we realized the problem was that we'd update Redis, we'd send a PubSub message for everyone to invalidate their data. Well, we were actually processing our own invalidate. If I'm server 1, I would write to Redis, I would send out a message, I would receive that message and say, oh my gosh, I need to invalidate my data. And so then this subsequent hit, it would actually go and reread Redis. So that one is a pretty easy one to solve. So we added when each client is instantiated, just grabs a GUID and it uses that as an instance ID. And then when it sends a message, we include the GUID. So now we can basically ignore ourselves if there's ever an update message. And by the way, so our actual sync messages, they're just that GUID and the 2-byte hash slot. So we have an 18-byte sync message. And it turns out when you have 18-byte sync messages, you can send a lot of those without having too many problems with network saturation. Another one too, and this is a constant theme in a lot of these sessions, you know, when you're using Redis because you want speed. And you're trying to minimize your TCP round trips. So in our case, we do an update to Redis, we want to send out a message, and we really don't want to do 2 TCP round trips. So we use Lua, and we just write a little script, and then basically when we update the data, the Lua script sets the value and then sends this PubSub message. You certainly could do, we are a Microsoft shop, we're using Mark Gravel's Stack Exchange at Redis library. You could also do batches if you wanted to, but because it was a little chance to do something fun with Lua. Still a couple little outside issues. So because we're invalidating groups of keys at a time, so you theoretically could have cache thrashing where basically 2 keys that share the same hash slot keep updating and keep invalidating each other. You could expand, we're going to 16,000 hash slots. We could expand that to more. That would minimize the problem. Really, we've been using this for I'd say about a year in production. We haven't run into any issues with it. One of the things that hit me too that you don't run into issues with is that, so this is not like going to a SQL backend where cache miss could be, you know, it could be a pretty resource intensive process. We're going to Redis, and you know, it's okay if we have to hit Redis a bunch of times because it's really fast. You know, we're looking at maybe, you know, under a millisecond extra time added to the read. We don't handle lost sync messages well. Because basically we just use the PubSub, and if someone were to unplug a network cable, that would get lost. And we degenerate down to the original case we had, where we just wait for that cache to expire. This is something that's kind of fun, learning a lot of things. Learning a lot of things here at RedisConf 18, just looking at like the streams and stuff. I'm trying to look at different ways that we'll be able to we could have a more reliable way to do this, but just we haven't tackled it yet. Future plans. So we're using PubSub to sync. In other products or other parts where we're using Redis more as like a primary data store, we actually discovered PubSub is just great for collecting hit-miss statistics across clients. And you know, normally we have an in-process cache installed in many, many clients, and you start saying to yourself, well, you know, what's the hit-miss ratio? It's easy to see it. You could, you know, jump into any instance and look at it, but how do we actually aggregate this data really easily? And you could write it to a log file, and you could use log shippers and all this stuff, or you could just publish that data on via Redis PubSub and just have a listener that picks up and aggregates all that data. So that's something we'd like to add to our cache. XFetch, which was a session actually last year here at RedisConf. It's a way to optimize when caches reload. That's something I'd love to do. Support more Redis data types. So with our caching, it's just strings. It's key value binary stuff. For other things, we've been using sets and things like that. And that's really when you get you really see the power of Redis when you start exploiting those other data types. And I just haven't had a good way to generalize an access pattern to those things. It's kind of funny too. One thing I didn't have on this slide. So again, things you learned at RedisConf. Salvatore, you had talked about having like hotkeys, and you know, so that this whole concept of, you know, we have all this data cached in Redis, and there's certain keys we're going to hit more than others. And basically keep track of those things. And the ones that are hot, we'll put those on the in-memory cache. I thought that was a pretty neat thing that I had never really thought. You know, you hear it and you're like, of course. Well, I hadn't thought of it before that. It's also, I feel bad for Mark Gravel because I just kept chasing him around asking him questions all day yesterday. And we were comparing notes on caches. And so they're actually at Stack Exchange, they're using something where when they write value to the cache, they can basically flag, do I want to put this in memory, or do I just want to leave it at the Redis layer? And I thought that was a decent approach too that we're not doing. So in the end, what we've got here, it works pretty well. We really have minimized the cache lag. We really have no issues with inconsistency across servers. So apparently we haven't lost any PubSub messages, or if we have, no one's told me about them. Reasonable network traffic. I'm actually really happy with that. Like I said, our message is 18 bytes. So there's really not a lot of data going through the network, and we were trying a few stress cases to say, how many changes, how much data can we, or changes can we log at a time? And the answer is quite a few. Another great thing, there's nothing else to deploy. If you're already using Redis, you've got everything's here. You don't have to go to your infrastructure team and say, oh, I need to install this, I need to install that. And you just connect up and go. I do have, so our actual implementation at Paylocity, we have a lot of usage patterns that are very specific to our data structures and stuff. So I did do a very simple example implementation that you can get here that you can just kind of goof with. And it's as simple as it gets, but it shows the ideas and gives you a starting point to goof around with it. With that, I'm actually done. A little ahead of schedule. Questions? Was someone
all this work worth it? I mean, have you measured the
Yeah, oh yeah, yeah. It depends on the exact hardware, but at minimum, I think we were seeing like 45 times faster to get stuff out of memory. Yeah, the bigger problem we actually have right now, so the way we did this, we originally implemented just the Redis-only cache, and then we implemented another caching package with the same interface with the in-memory layer. And the thought was for consumers that needed really fast access, we'd steer them, hey, use this one, this implementation with the InProcess Cache. And basically what's happened is everyone's discovered it, and everyone's like, regardless, I only use this value once every 10 minutes. I want it in memory. So we actually see nothing out of control, but people have been seeing on all our servers a higher memory usage, and it's like, well, what's going on? And it's actually because everyone's using the in-memory cache.
And what's your in-memory cache right then?
What's that? Oh, what is our in-memory cache? So we're a .NET shop. It's actually just the default Microsoft memory cache. Yeah, nothing. There's not a lot of really surprising stuff here. It's actually very straightforward. Yeah, I'm sorry. Do we have the microphone around, or my hearing is horrible, to be honest. So. You're quiet and I'm deaf, so between the two of us, we're not doing too good. I think bring up a microphone. Thank you.
So what I'm trying to meant, like when you say in-memory cache, so I can assume that it can be EH cache or any other coherence cache, it can be like this, right?
It could be, yeah.
Yeah, so in that case, you all the time make a synchronizations with the Redis cache.
Yes, I mean, I guess I'm not quite understanding your question.
So when you do the in-sync, the data cache,
yeah.
So always you do the sync because the data comes into the local cache first.
Right, yeah. So whenever we write, we'll write to the local cache and then write to Redis.
Then you make the synchronizations from the local cache to the Redis cache, right?
The synchronization is actually between all the instances of this local cache. So, so say someone wants to write a value to our cache. So actually, we'll write to Redis first, get that value in there. We'll put it in our local cache on our server, and then the synchronization message is actually out to all the other clients saying, this key is updated, or this HashSlot, the HashSlot of this key is updated. And now if you need to read data, you need to go back to Redis to say, what is the correct data? Because whatever data you have on some other server in your in-process cache, could be wrong. It could be outdated. I don't
Got it. Because I was looking a solution other way around. The in-memory cache, the data will update first, then I will make a sync with the Redis later. But what you are doing, you are updating, you have the fresh data into the Redis, then you are asking the in-memory to make a sync.
Yes, right. We're basically right. We're telling everyone else right to make the sync with the memory thing. But they're only going to do that sync if someone actually requests that value. So one case like say this is our first server and we say we invalidate HashSlot 100. The instance of the cache over here will just get a message that HashSlot 100 is invalid, but it won't actually do anything unless someone actually asks for hits that and says I need to get this value for this hash for this key. We take the hash slot of the key and says, oh, guess what? This is my value is out of date, so now I'm going to go to Redis, and when I do that, then I'll bring that value over and I'll plop it in my in-process cache. But I won't, unless someone requests data, I won't actually bring it over.
Thank you.
You're welcome.
So what you're doing is close to a zero-knowledge cache validation. If you look in zero-knowledge proofs, it's very similar to that.
Okay.
It's very clever, actually. Thank you.
Oh, thank you, thank you. Yeah, you had mentioned cache. So we're a .NET shop, a Microsoft shop, and it was kind of funny when I was looking around. I always have a fear, like when I do some presentation, someone's going to come up and say, "Duh, you missed something completely." For example, I did not realize Redis had the key notification. We had started with I think 2.6, and they didn't have that. And someone mentioned it during the conference, and I was like, oh my God, did I miss this completely? And if we were able to just push around keys, that would be a great way to actually move, push that data around. But in this case, again, we really like that hash slot because it kept the messages very, very short. Yes?
Hey, I have a question. So when I got a sub message, and let's suppose I have 5 instances, out of them 1 didn't get the message because of network, disconnect.
I'm sorry, I'm not hearing.
Do you want me to
pretty
leave it earlier? Oh, sorry. So if I have 5 instances and out of 5, 1 of them didn't get the message for subscription, then what happens when there is a call comes in there and I need to go and get the HashSlot 100, which is already expired on this instance. So how it works?
I'm sorry. Could someone understand it better than I am?
Oh, okay. Let me rephrase the statement. So out of 5 instances, if one of the cache on local didn't get the update notification.
Oh,
I think what he's suggesting is that if the PubSub message wasn't received,
yeah.
then the local cache would be operating with invalidated.
Yeah, that's correct. Yeah, that's what happens if the PubSub message isn't received, right? Yeah, in that case, right, the local cache will be working with invalid data and think that it's current because it's just the last updated array was not updated, and this is definitely it's a hole in what we have now. It's a case we haven't addressed well. We've been lucky, I guess, in that we really haven't had a problem with this because apparently our networking guys are pretty good and we don't lose many messages. The other thing too is that whenever we write to the in-process cache, we are giving it a time to live. So it won't be that you'll never see a value, you'll never see an update, but after a couple minutes, say, or however they configure it, then you will get the value will fall out of the local cache and you'll just have to go to Redis.
Oh.
Anyway.
Also to your invalidatable hash slots.
Yes.
You probably will get an update for that.
Yeah. One thing I haven't done a lot with is
No, he was saying that the invalidation message that they get is by hash slot, so it could be the case that some other key will trigger a refresh of this database.
yeah.
Even if you miss the previous hash slot, because you'll probably get the same hash slot.
And the real key to all this working too is, if you had to go to like a SQL backend and you started invalidating whole groups of keys at a time, you'd have a performance problem. But because Redis is quick enough, it's like, okay, I don't have an optimal solution here, but it's really not that much more time to hit out. It's good enough, yeah.
So in Redis, you're not using TTLs because it's the source of
We do use TTLs in Redis too.
How is it the source of truth then?
It's the source of truth. Yeah, it's the source of truth for the cache implementation.
Oh, okay.
Yeah. We do have. I'm sorry. Yeah, it's in kind of a local scope of for this cache implementation. Redis is a source of truth. We do have some other thing. We're starting to move more towards Redis as a primary data store. But so Paylocity's been around. The original code was written in I think 2001. So we have a mountain of code all written against SQL Server. So it takes some time to migrate this stuff over.
When you do it right, when does it actually make it into SQL Server?
So this is just a cache. So actually, this data doesn't. We never write it back to SQL Server. This would be more the usage pattern on this is if it's not in the cache, I'm going to go to SQL Server. I'm going to figure out what data I need, and then I'm going to plop it into this cache implementation. And this cache implementation will say, okay, I'm going to write it to the InProcess cache. I'm going to write it to Redis. I'm going to send out that sync message to everyone else. But yeah, the actual typically what we'll see is right. We've got user demographics in the database, and we'll load that, and then someone say, oh, I need someone's username. Is it in the cache? No, I'll go to SQL Server. So in the entire system, the real source of truth is SQL Server. But once it gets in the caching infrastructure, Redis is what value it is. You go to Redis.
And for people who are not familiar with Redis, he's relying on the O@1 nature of a lot of data structures in Redis, whereas SQL Server is not O@1.
No.
So he gets a massive increase in performance on validation.
Yeah. More questions? Oh my gosh, we got lots of questions today. Yes.
Sorry, I came in kind of late, so if I missed this, I apologize. But so what if the node crashes before it actually syncs up with that?
So the node crashes.
While it's in the cache, but it hasn't actually synced up with the database.
Yeah, it's asking what happens if the node crashes, how we would sync up data. So we wouldn't sync up data with SQL Server. So when you say one of the nodes that has this in-process cache crashes, so when it would come back up, there's no data in the cache. So every time someone would make a request to that cache, this fresh cache, what will happen is it'll say, well, is it in the in-process cache? No, because we just brought up, okay, now we'll go to Redis, and we'll pick up the value out of Redis, and then populate our in-process cache of that value.
Okay. So Redis is just doing the reads from SQL Server, basically, right?
Yeah, I mean, we actually have, not in in the caching implementation, but we actually have another spot where we are doing pushes from the database. Again, all our stuff, it's legacy SQL Server stuff, so we do have some things that do pushes from the database that actually inform Redis through a service to say, hey, data has changed, and then we'll update Redis there. And this is, something we could possibly do here, but again, this is something we just wanted to drop in place of like a local in-process cache. That this gives us a little more because now we're not having problems with cache inconsistencies across servers. More questions? Oh my God.
I noticed that you were suggesting that perhaps as a future feature, you were going to use PubSub for metrics on.
Yes.
Have you considered using the time series model that they were talking about?
Yeah, so the question was, we're talking about using PubSub for publishing, or basically aggregating publishing statistics. What about maybe using the time series? That is why I was in your session on time series. Yeah, it's something that we haven't looked into yet, but it looks like it has a lot of, there's a lot of good things that we could do there. We haven't explored them yet. Okay.
So basically, the idea is in the next months to implement this as a service inside Redis to help to model this pattern with the help of the server. However, there are so many models possible. One is, for example, this thing of the HashSlots is like basically is like a Bloom filter in some way. You say I can have a subset of the possible keys, so you just inform me about this subset. Another is completely tracking every key that the client declared as I'm caching that.
Yeah.
So remember this. Maybe with also a TTL, I can say as a client, I'm going to caching this for 5 minutes. So after 5 minutes, don't bother about notifying me about the change because at this point this is better. what do you think could be a good way to pack this kind of things? And I know it will require like 1 month of work to reply to this question, but as you say, as you are now in this moment after giving the talk, what do you think could be like a set of minimal features to pack this as a...
Yeah. It's a good question. Salvatore's asking, essentially, how can Redis server, I mentioned that I was very happy in the keynote where you're mentioning about the next thing you're looking at doing, some way to help facilitate this in-process stuff. And I was just like, yes, this is great. So I have to think about it. I wish I had a better answer, but I'm not quite sure what would be the best way. It's something I just need to think about a little bit.
Do you want to be part of this process? Like,
oh, absolutely, yeah.
Start a discussion?
Yeah. You have no idea how excited I was. My wife's with me, and I was just like, because it was something you had actually mentioned last year a little bit about for 4, and then so I was kind of looking, and it looked like it kind of got backburnered. So I was very happy to see, but yeah, I'd be very interested because again, this is a simple solution. If you look at the source code, you'll actually look at it and you're like, you got to be kidding. I mean, it's like an extra 20, 30 lines, but it has just really great performance enhancements and stuff. And so that got me really excited. It gets me even more excited if we have some better integration, where we're doing something better with Redis actually helping us invalidate stuff easier. Thank you. You get a lot more thanks than I should get. Thank you. Other questions? I think we're actually over time, so. Thank you, guys. Thank you.